All right, guys, today we're going to continue working with trig and introduce a new concept, just a little different thing, different wrinkle that we can do with trigonometry. Today we're going to focus on how to find the measurement of angles when we know their sides, which is another application of trigonometry that's kind of interesting. In order to do this, we need to understand, number one, where and kind of how to punch things into our calculators correctly, and then we just got to execute it. In order to find the measurement of angles, what we're going to use are called inverse functions. You can find these functions by looking at your calculator and hitting the shift button, which is in the upper left-hand corner, and then any of our three trigonometric functions, sine, cosine, or tangent. And what this does is it shows something that looks kind of like this: sine -1, cosine -1, or tangent -1. What that means is, they're referred to as inverse functions, which means if we know the ratio, we can find the angle. So we're going to try this out. We're going to start with finding the measurement of angle A, which is in the top right corner. All right. Now we could estimate that to be probably the smallest angle of this triangle, maybe right around a 30-degree or a 35 or 40-degree angle. And based on the side length 12 and the side length 24, we're going to be able to come up with what that angle A should be. Now, since the cosine is the adjacent leg over the hypotenuse, in order to calculate what that measurement would be, we would use an inverse cosine. We would do the cos -1, which you would find by hitting shift and then the cosine button. Then all we're going to do is we're going to write out that ratio. Okay, since the cosine is the adjacent over hypotenuse and the adjacent side would be here, we would write out 12 over 24 and then hit equals, and it's going to tell us exactly what the measurement of that angle is going to be. All right, so if we do cos, and you guys can all kind of follow along with me, or I should say shift cosine and then type in 12 divided by 24, it's going to tell you that that should be a 60-degree angle. Okay, 60-degree angle, which actually I was off on that. I was estimating angle C, I think. But yeah, 60 degrees, that makes sense. This should be a 60-degree angle. And it turns out this is going to be one of our special right triangles. Right, we can find angle C by simply knowing that all the interior angles must add up to 180. So that means that this is a 30, 60, 90 triangle. 30 degrees there. So it's kind of a cool another application to trigonometry. Let's take a look at another example here. In a right triangle, the side opposite of angle A is 8 millimeters long, so we'll label that 8 millimeters. And the hypotenuse of the triangle is 12 millimeters long. 12 millimeters. Question is, what is the measurement of angle A, and then what is the measurement of angle B? Which angle B is a 90. We're going to find A and C. I'm not sure why it says A and B. We're going to find angle C. So first thing, let's start with A. I just like to circle the angle, identify what the 8 and the 12 are in reference to that angle, which would be an opposite side length. This is opposite, and then a hypotenuse. Okay. Opposite over hypotenuse would be a sine function. The sine of an angle is equal to the opposite over hypotenuse. Remember our SOHCAHTOA. So what we're going to do then to find the measurement of that angle is we will use the inverse sign. We will do the sine -1 of that opposite over hypotenuse, which in our situation here is going to be 8 over 12. Right? And what it's going to tell us is that any triangle that has a ratio of the opposite side being 8 and the hypotenuse being 12, what the angle would actually have to be. So we're going to do our keystrokes. Shift, sine, and then 8 over 24. If you guys can all do that with me if you have a calculator, then hit equals. It's going to tell you that that should be about a 41.8 degree angle. 41.8 degree angle would be this angle right here, 41.8. Then if we wanted to find C, we could simply take 90 degrees and subtract our 41.8. And we would know that angle C should be a 48.2 degree angle. 48.2 degree angle. All right, so it's a cool little function within trigonometry is we're able to calculate what the angle should be knowing the side lengths. Try another example here. We're looking for angle x in this case. All right, so we're just calling this angle x. We identify that angle. 17 would be adjacent to x. Or adjacent means it's touching the angle, but it's not the hypotenuse. And the 32 would be the hypotenuse. Okay, so if we can just all think here, adjacent hypotenuse, so ka toa, this looks like we're going to be using a cosine. All right, so to set up the problem and solve for angle x, we're using inverse cosine. We'll use the cosine -1 of that 17 over 32. And it will tell us the measurement of that angle. Keystrokes would go shift cosine 17 divided by 21, 17 divided by 32, and hit equals. And it's going to tell us about 57.9 degrees. 57.9 degree angle would be angle x. Another example here, just kind of giving us a larger frame of reference. We'll try and make this a little bit larger for you. Sorry for the blurriness. So we've got our x angle right here. This is what we're trying to solve for. This is an opposite side length. This side is not a hypotenuse. This is actually the adjacent side length. Opposite over adjacent would be a tangent function. Tangent is equal to opposite OPP over adjacent, ADJ. And then we're just using our inverse tangent function to calculate the angle. Tangent -1, tangent -1 of that opposite 13 over 18. And we'll punch it in, inverse tangent, 13 divided by 18. Close off our parentheses and hit equals, and it tells us it's about a 35.8 degree angle. Okay, you'd be amazed at how accurate this actually is when you deal with real right triangles. All right, last example for our notes. So this one here, we've got, again, I'll make the triangle slightly larger. Okay, we're looking for x degrees. X degrees is given there, and we need to identify our sides. 21 is exactly opposite of our angle, and 28 is the hypotenuse since it's opposite the right angle. Opposite over hypotenuse, that seems like that should be a sine. Sine function, which, again, not sin. Sine function, 21 over 28 would be opposite over hypotenuse. Okay, so we type it in. To find the measurement of the angle, we're doing the -1 function. And we're punching in that this would be 21 to 28. Sine of a -1 sine, or the inverse sine of 21 over 28. If you guys could all punch that in. Hit equals, tells us the angle should be 48.6 degrees. So this is a 48.6 degree angle. Now remember, don't trust a protractor on your assignments because the books oftentimes try and trick you. Really stick to the math behind it as opposed to trying just measuring the angles. Okay, so hopefully this was helpful. You guys will have an assignment on this today. Good luck.